Instantaneous center of rotation in plane motion. What is instantaneous center of rotation in plane motion? Plane motion of all particles in a slab can always be replaced by the transportation of an arbitrary point A and a rotation about A with an angular velocity that is independent of the choice of A. The same translational and rotational velocities at A are obtained by allowing the slab to rotate with the same angular velocity about the point C on a perpendicular to the velocity at A. The velocity of all other particles in the slab are the same as originally defined since the angular velocity and translational velocity at A are equivalent. As far as the velocities are concerned, the slab seems to rotate about the instantaneous center of rotation C. If the velocity at 2 points A and B are known, the instantaneous center of rotation lies at the intersection of the perpendiculars to the velocity through A and B. If the velocity vectors are parallel, the instantaneous center of rotation is at infinity and the angular velocity is 0. If the velocity vectors at A and B are perpendicular to the line AB, the instantaneous center of rotation lies at the intersection of the line AB with the line joining the extremities of the velocity vectors at A and B. If the velocity magnitudes are equal, the instantaneous center of rotation is at infinity and the angular velocity is 0. The instantaneous center of rotation lies at the intersection of the perpendiculars to the velocity vectors through A and B. The velocities of all particles on the rod are as if they were rotated about C. The particles at the center of rotation has 0 velocity. The particle coinciding with the center of rotation changes with time, and the acceleration of the particle at the instantaneous center of rotation is not 0. The acceleration of the particles in the slab cannot be determined, as if the slab were simply rotating about C. The trace of the locus of the center of rotation on the body is the body centroid, and in space is the space centroid. Examples. 1. At the instant shown, what is the approximate direction of the velocity of point G, the center bar AB? Answer letter C. 2. The double gear rolls on the stationary lower rack. The velocity of the center is 1.2 meters per second. Determine A, the angular velocity of the gear, and B, the velocities of the upper rack are in point D of the gear. Strategy: the point C is in contact with the stationing lower rack and instantaneously has 0 velocity. It must be the location of the instantaneous center of rotation. Determine the angular velocity about C based on the given velocity at A. Evaluate the velocities at B and D based on their rotation about C.